Hello students, welcome to section 1-3, solving equations with a variable on both sides. We're going to go ahead and kick things off today just to introduce again kind of how the modeling of sorts will take shape. This particular example, similar to an example that we have seen in the past to kind of kick the lesson off, is an example of how precisely we're going to be using solving equations in context. So some friends want to see a movie that is showing at two different theaters in town. They plan to share 3 tubs of popcorn during the movie. Theater A highlights $14.50 per ticket, while Theater B highlights $13 per ticket. Per popcorn tub is $5.75 at Theater A, while at Theater B it's $6.75. So here are some of the things that we'll be able to do once we get through this particular lesson. We'll be able to construct arguments. For example, which movie theater should the friends choose and explain. We will also be able to, for example, understand for what situation would the total cost at each theater be exactly the same and explain. And then lastly, for example, there are different methods to solving this problem, but which do you think is the best and why? So let's take a look. Example 1. There are 2 parts to this example. It says, what is the value of x in the equation shown? And as you can see, 3x minus 10 plus 4x equals negative 2, quantity x minus 4 plus 9. To kickstart this problem, we see that we have like terms on the left side of the equation, of which when you add 3x and 4x, you get 7x. So in the next step, 7x minus 10, and that equals, on the right side, if you distribute the negative 2, negative 2x, and then what? Plus 8. Be careful with your signs. Plus 9, of course, still carries down. So in the next step, we can go ahead and do the following. We can balance our equation by adding 2x to both sides and at the same time add 10. Now be careful when you do this. You do want to make sure you add 8 and 9 as well, which of course is 17. Add 10, you get 27. 7x plus 2x, that adds nicely to be 9x. And there in the next step, you can see the math dividing both sides by 9 leads to the answer of x equals 3 quite nicely. Part B, what is the value of n in the equation shown? So as we've seen in the past with certain algebraic equations, one of the nicer things you can do to make your life a little bit easier is multiply, in this case, by, and this, as you can see, 2 as it relates to, well, getting rid of, so to speak, this fraction. You won't have to deal with a half if you multiply it by 2, because 2 times a half, as we hopefully recall, is just 1. You do have to be careful though. 2 does need to be distributed not just to the first part, but also to this negative or minus 7 piece. So 2 times negative 7, that's negative 14. The n minus 4 is all that's left in that particular quantity, because again 2 times a half cancels, so to speak, to be 1. On the right side of the equation, distribute the 2 to both of those. You end up with negative 4 on plus 12. Balancing the equation is pretty straightforward. You can add 4n to both sides, but also add 18 to both sides. The reason I added 18, well, negative 4 minus 14 is negative 18. The opposite then being positive 18. When you add 18, these cancel on the left side. 12 and 18 add to 30. Adding 4n over here, of course, you can see then, hopefully, that 4n plus 1n, that adds to 5n. Those are like terms. Then, of course, you see 5n equals 30. Easily enough, divide both sides by 5, and boom, n equals 6. Let's move on. Example 2. And there are 2 parts to example 2. It says, what is the value of x in 4x plus 6 equals 2 times the quantity 2x plus 3. So it says to use algebra tiles to represent and solve 4x plus 6 equals 2 times the quantity 2x plus 3. So I'm going to go ahead and do that. I did something where I can kind of pull down the steps. I do like how the book does this with algebra tiles. Obviously, I can do this in a different way. Maybe I could redraw the algebra tiles for you in the future, but this is I think a nice quick way to represent that if you did have these tiles. So you have 1, 2, 3, 4 green tiles, which represents 4x. There's 4 of the longer, as you see, tiles, 4x therefore, plus, and then you have 6 of these smaller just simple square yellow tiles. And to that, we're going to go ahead and set it equal to 2 times 2x plus 3. Now it does show here, and I do need to kind of highlight where this comes from. Use 2 groups of 2x plus 3 to represent 2 times the quantity. So this is 1x, 2x, and then plus 3. This is 1x, 2x, and then plus 3. So there's 2 times, again, 2x plus 3 groupings. So because we're equating the two, as we continue down, I'm going to go ahead and show you how this would play out. We're going to go ahead and do the math where if we subtract 4x from both sides, so you're actually going to subtract out the groupings of the green rectangles from both sides, 4 minus 4x. Imagine again, if you will, if you were balancing the equation, subtracting out the 4x from both sides. Well, this right side already has a 4x, or excuse me, the left side already has a 4x, while the right side would as well after you distribute the 2. We're not touching the 6 yet. Well, what happens here is that when the 4x's are subtracted, all you're left with are the yellow squares. So on the left side you have 6 yellow squares, and on the right side you have 6 yellow squares. And because 6 equals 6, that's true, and it's always a true statement, it is equivalent to the original equation. The equation is true for every value of x. So our final answer, as you can see, is indicative of, well, this side of the equation equals that side of the equation is true for all values of x. An equation that is true for all values of the variable is called an identity. In part B, we'll go ahead and do a similar type of kind of analysis, except we'll actually do the algebra without making algebra tiles or seeing the algebra tiles kind of work their way out. In this case, 6x minus 5 equals 2 times the quantity 3x plus 4. If you distribute the 2, on the right side you'll get 6x plus 8. If we subtract 6x from both sides, they cancel out on both sides, leaving us then with negative 5 equals 8. Now I crossed off the equal sign. That's my way of highlighting that, of course, negative 5 is not equal to 8. And because that's not true, this problem actually has no solution. There is no value for x, in other words, that will make this a true statement. No solution. And that symbol actually is how we're going to interpret that in the future, no solution. And it'll be utilized quite often in similar situations. Let's move on. So example 3. This is a similar problem actually to one we've seen in the past when we did, I think, an acid solution mixture problem. It says Arabica coffee costs $28 per pound and Robusta coffee costs $8.75 per pound. How many pounds of Arabica coffee must you mix with 3 pounds of Robusta coffee to make a blend that costs $15.50 per pound? So again, I kind of like how they did this, and organizationally, using a table is a very smart thing. I did in a prior example, if you recall, with the acid mixtures, I used kind of a visual aid to help. So what I see here, and I would argue this is just as good, if not better, than a lot of the other questions maybe you'll be able to interpret and organize it in this manner. Particularly, you've got Arabica coffee. The price per pound is 28. Robusta, 8.75. Now you don't know A. A is going to be the amount in pounds of the Arabica, and then 3 is what we know to be the pounds of Robusta. The total cost we don't therefore know for Arabica, so 28 times A. We do know though $26.25 simply by multiplying 8.75 times 3 for the Robusta. The coffee blend that they're asking us cost per pound in the end to be $15.50. The amount, A plus 3, in other words, we do know the Robusta, but we don't have the Arabica. So A plus 3, if A ends up being 12, for example, the total pounds will be 15, for example. That particular expression might be the most interesting of all, in that we're taking what, of course, the cost was in the end, or what we want to be, and we're multiplying it again by, in this case, A plus 3. Okay. Keep in mind, we don't know the number of pounds of Arabica. We don't know the total cost exactly. However, 28A is a nice way to interpret and set ourselves up. And then in the end, we also don't know the pounds of the full blend. So A plus 3, whatever A is, we're going to add it to 3. And in this particular expression, add it to 3, but also multiply it by $15.50 to have the total cost of both combined. As we continue, it says write an equation to represent the situation, which we're about to do here and highlight. So you can set up the equation as such: 28A plus 26.25 equals 15.5 times the quantity A plus 3. So you're adding two different values that end up being dollar amounts in the end, and you're setting it equal to the dollar amount times the quantity that we noted, A plus 3, not knowing A yet. In the end, dollars equals dollars. Units are going to cancel quite nicely in that regard. The algebra speaks for itself in the next step. Distribute, balance the equation, add and subtract like terms, and then divide. In the end, you'll end up with 1.62. And remember, that's A as pounds of Arabica coffee. So if we go through and highlight all the details to finalize our answer, you must mix 1.62 pounds of Arabica coffee with 3 pounds of Robusta coffee to make a blend that costs $15.50 per pound. In the end, 1.62 plus 3 is 4.62. So that'd be another kind of finishing touch you can put on it to make it hopefully all come together. But yes, it does work out. If you plug all the numbers back in, you'll have $15.50 per pound. Example 4. Use equations to solve problems. Cameron pays 95 cents per song with his current music service. A new music download service charges 89 cents per song with a $12 joining fee. Should Cameron switch to the new service? Okay, so let's take a look. I do like, again, how they've kind of presented things. Write an equation to represent when the cost for any number of songs is S is the same for both services. So the new music service is equal to Cameron's current music service. When are they going to be equal? Let's see. So we know 0.89 or 89 cents times the number of songs plus $12 to start or join should be equal to 95 cents per song with his current service. Notice the 0.95S quantity is not added to anything because he doesn't have to pay the joining fee with the current service in blue. Solve the equation to finish the number of to find the number of songs at which the cost for each option will be the same. All right, the equation hopefully makes sense in that we're solving for S. The red is the new, the blue is the old. So we go ahead and solve. We go ahead and balance our equation accordingly. We subtract 0.9S. We're left then with 12 equals 0.06S. We divide by 0.06. And if we finish this off, we can hopefully see, slide this down, 200S is the end result. The cost of the two options will be the same for 200 songs. If Cameron plans to purchase more than 200 songs, he should switch to the new service because it will cost less than his current service. But if he only plans on buying 200, it's a wash. He should either decide to stay or go new, and it's not really going to matter. So that concludes example 4. Now, there's no more examples beyond this, but I do highly suggest that you take a look at some of those try it problems just to kind of, I don't know, reaffirm, I guess you could say, some of the concepts we've went over, and also look at these problems in a different way.